Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to continue our series of videos on statistical method 1, right? So today we are going to discuss measures of variations. We have about 5 measures of variations. We have range, deviation, population variance, sample variance, population standard deviation, and then sample standard deviation. These are the 5 measures of variations that we have. So we are going to discuss them one by one and look through at the formulas, and then also we will solve examples for us to really appreciate whatever we are going to discuss here. Yes, so here we have what we call range. We said when we talk about range, a range is just a difference between the maximum and the minimum data entries in the data in the set. So for instance, if a raw data is given to you and then you have been asked to calculate for the range, it's just the difference between the biggest number in that raw data and the smallest number, right? Once you indicate both of the biggest and the smallest number, you just subtract the smallest from the biggest to get what your range. And then we have what we call the deviation. The deviation is the difference between the data entry x and the mean of what the data set, right? So the x will be what the raw data, right? The individual values that we have, that's the individual values that what we have, that's the x, right? And then the mu, right? The mu is what the mean of the data set, right? So x minus what mean, right? X minus what the mean. This is called what the deviation, right? X minus what the mu, right? Or it can be written as x minus what x bar, right? So this is called what the deviation, right? The deviation is simply the difference. You find the difference between the entry data entry x and the mean of what the data set. So when a raw data is given to you, we are going to find the mean of the raw data and subtract it from what the individual what data set. So that is what the deviation. And we have what we call the population variance, right? The population variance in mathematics is usually represented by what sigma square, right? So the population variance is what you are going to just sum the x minus mu, that's the deviation all squared. So you are going to just square the deviation of all the individual data entries and then sum them and divide it by what n, that's the capital N. The capital N here is what the total, the population total, right? And then we have what we call the sample variance. So the sample variance is usually represented by what x raised to the power square, right? And then this one too is what the summation, right? The summation of what x minus what x bar all squared, right, divided by n minus 1. So there is a little bit difference between the sample variance and the population variance. The sample variance we saw here to be what x bar, but for the population variance we saw the mean to be what mu, right? The mu here is what the population mean, and then the x bar here is what the sample mean, right? And here you see capital N. The capital N is what this n is what the total n, right? That's the population n, right? The population total number, right? Here the small n is just telling us that this is what a sample number, so n minus 1, right? So that's the little difference between the population variance and the sample variance. So please kindly take note of this, right? These formulas, because we are going to use it to solve a lot of what examples, right? And then we have population standard deviation. That's represented by what sigma, right? So it's just square root of what the population variance. They are just going to square root what the population variance, and the sample standard deviation, you are just going to square root the sample variance, right? So this is what the formulas that we have for the measures of what variation, right? Let's dive into examples. It says find the range, sample variance, and the sample standard deviation for the data sets, right? So this is the data set. We have 10, 12, 13, 15, 25, and 30, right? So our first question was we were asked to find the range, and in the explanation I told you that the range is just the difference between the maximum and then what the minimum number in a given data set. So within this one, I'm just going to locate the maximum number, right? We could see clearly from here that our maximum number of this data set is what 30, and the minimum is what 10. So here I'm just going to subtract 10 from what 30. as you have seen them, as you have seen the solution here. So 30 minus 10 is going to give us what? 20. So the range of the above data set is what? 20, right? And then we have been asked to calculate for what? The sample variance. And we know that the sample variance x squared is equal to what? Summation of what? X minus what? X bar all squared divided by n minus 1, right? So we have to get our summation for x minus what? X bar, right? We have to get x minus what? X bar, right? So this is a raw data set given to us, and for this raw data set we were not given the mean. So the first thing that you have to do is to get the mean. Once we get the mean, we are going to just subtract the mean from what? The individual data set, right? So here, let's find the mean. So the mean is what? We know that our mean, I'm coming. We know that our mean, that's x bar is given as summation of what? Xi divided by what? N. So we are just going to sum all the data set that we have here and divide it by what? Our small what? N, right? So here we are going to sum 10 plus 12 plus 13 plus 15 plus 25 plus 30, right? So here will be 10 plus 12 plus 13 plus 15 plus 25 plus 30 divided by what? 6, right? So this is what we are going to have. So once we have this one, right, when we add it well and divide it by 6, we are getting 17.5. So right now we have been able to get our mean. So all that we have to do is to find our deviation, and we know that the deviation is x minus what? X bar, right? Yes. So here, this is what? Our individual data point, right? 10, 12, 13, 15, 25 and 30. As we can see here, that's our individual data point, right? So we are just going to subtract our mean, that's 17.5, from all these, and then square it and sum to get what? This one, and then divide it by what? Our n minus 1 to get our sample standard deviation, right? So here, for the deviation, we are just going to subtract the 17, right? We are just going to subtract the 17.5 from the individual data set, right? So here, 17.5, when you subtract it from 10, right, we are going to get negative 7.5. When you subtract 17.5 from 12, you are getting what? 5.5, negative 5.5. When you subtract 13 from when you subtract 17.5 from 13, you are getting negative 4.5. When you subtract it from 15, you are getting negative 2.5. When you subtract it from 25, you are getting 7.5. And when you subtract it from 30, we are getting what? 12.5. Note, this is what? Just the mean deviation, right? But I have to square the mean deviation before we can sum, right? Yes. So because the formula for the variance is just telling us, I'm coming. The formula for the variance is just telling us that our s square is equal to sigma of what? X minus what? X bar. Sigma of x minus x bar all squared divided by what? N minus 1. So we cannot use the summation for this one to calculate for what? The sample variance. We have to square it, right? So squaring the deviation, negative 7.5 square will give us 56.25. Negative 5.5 square will give us 30.25. Negative 4.5 square will give us 20.25. Negative 2.5 square will give us 6.25. 7.5 square will give us 56.25. And then 12.5 will give us 156.25, right? So this is what we are going to have. And then we have to just sum everything. So sigma of x minus x bar all square is equal to 325.5. So this is the total that we will have. And then right now we have to calculate for our n, right? This is the data set. So if you want our n, right, if you want our n is just counting them, right? So we have 1 2 3 4 5 6. Our n is equal to 6, right? So here our n is giving us what? 6. So once we have our mean deviation, we have the summation of x minus x bar all squared, and then we have our n, right? And then we have our n, the work is done, right? Yes. So right now we know our formula, so we are just going to substitute it inside, right? So here we are going to get our s squared to be what? 325.5 divided by 6 minus 1. Of which when you come down here, that is what they have done here nicely for us, right? So here we have 225.5 divided by 6 minus 1, and of which the total is surely going to give us 65.1, right? 65.1. And then we are asked also to calculate for the sample standard deviation. The sample standard deviation is just the square root of the variance. So here we are just going to square root what? The 65.5 to get what? Our standard deviation. Square root of 65.1 is giving us 8.07. So that is the solution to this question, right? That's the solution to this question. So let's continue. I have another example here. You have another example here. So here it said find the range, the sample variance, and the sample standard deviation for the data set 101, 112, 115, 117, 118, 119, 120. Right now we have been asked to calculate for our range, right? We know that our range is what? The difference between the maximum and the minimum value, right? So here our maximum value is what? 120, and our minimum value is 111. So you are just going to subtract our minimum value as 111 from what? 120 to get what? 9, right? And then we have been asked to calculate for what? The sample variance, and we know from our previous example that our sample variance S square is given as summation of what? Our x minus x bar all square divided by what? N minus 1. So we have to get our mean deviation and then square the mean deviation, sum them, and then divided by 1 minus 1, right? So here we have to find our before you can find the deviation, you have to find what? Our mean, right? So the mean is just summation of all the raw data divided by what? N. And we know that when our n is 7, so you sum everything divided by 7, we are getting what? 116. 116. So here for us to get the mean deviation, the mean deviation and the square it, we are just going to subtract 116 from what? X. That's the individual data set, individual data point. So 111. So here we are going to get 111 minus what? 16, right? When you 111 minus 16, you are getting 5. When you square the 5, you are getting what? 25. 112. So here will give us -5. Yes. 112 minus 116 is surely going to give us -4. When you score the -4, you are getting what? 16. 115 minus 116, right? When it's surely going to give us -1. When you square it, you are getting 1. 117 minus 116, you are getting 1. When you square it, you are getting 1 here. 118 minus 116, you are getting 2. When you square it, you are getting 4 here. 119 minus 116, we are getting 3. When you square it, you are getting 9 here. 120 minus 116, we are getting 4. When you square it, you are getting 16 here. So here you have to sum everything here. So when we sum, you are getting what? 72, right? You are getting what? 72. So here we are going to get, right now we have summation of x minus x by all square here. So summation of x minus x all square here, s by all square here. So we are just going to replace that one by 72, and then we know that our n is 7. So 7 minus 1, right? When you divide everything, you are getting what? 12 as what? Our solution. 12 as what? Our solution. So we are also asked to calculate for the sample standard deviation, and the square root of 12. Square root of 12 is surely giving us 3.46, right? So you could see clearly that this is not really something that is very tedious, right? Let's also try our hands on example that we are going to calculate for what? The population variance and the population standard deviation. All this example is talking about the sample variance and the sample standard deviation. Let's dive into population variance and the population standard deviation for us to really appreciate how we are going to calculate for the population variance and the population using what? The formulas, right? Yes. So this is the question. So here is our question. The question says find the population variance and the population standard deviation for the given data set. So here will give us the data set is 10, 60, 50, 30, 40, and what? 20. Here we are not asked to calculate for our our range. So you go straight to the point. So here is what? Population variance. In our formulas, when we were learning the formulas for the measures of variation, we came across how we will calculate for what? Let's go back and check. Yes, in our previous videos, right, I taught you guys about how we will calculate for the population variance and the population standard deviation. So if you haven't watched that video, please kindly go back and then watch, so that we are not going to waste much time here going back to teach you the population variance. Sorry, the how do you call it? The population mean, right? Yes. So we have the population mean and the population variance, right? Yes. So the population mean is usually represented by what mu, which is giving us summation for a raw data, summation of xi divided by what, our capital N, right? And for the sample, we are having summation of what, xi divided by what, small n, right? So this is how the mean is being calculated for the population and then the sample, right? So here we are just going to add everything here since you are calculating for the population variance, and then we know the formula for the population variance, right? The formula for the population variance is giving us sigma square, which is equal to summation of x minus what, mu all squared divided by what, capital N, right? So there is a quite different there is a difference between the population variance and then the sample variance. For the sample variance, you could see clearly that here is what, small n minus 1. But for the population variance, you could see clearly that here is what, capital N, right? So it means that we are not going to subtract any one from the n, which is surely going to give into, which is surely going to be given to us, right? Yes. So here we have to calculate for the mean and then get the mean deviation, the deviation, right, before we can calculate for the population variance and the standard deviation, right? So here we know that our mu will be summation of xi divided by what, our capital N. So here we have 10 plus 60 plus 50 plus 30 plus 40 plus 20. So we are just going to add everything here divided by, so when you do it correctly, we are getting what, 35 as what, our mean, population mean, right? And then we have here is our x's, right? So we are just going to subtract 35 from our x's. When we are done, we will score it and then sum it to get our distance, right? So when you subtract it from the x's, this is what you are going to get: negative 25, 25, 15, negative 5, 5, and what, negative what, 15, right? Yes. So when you subtract it, so when you square it, we are getting what, 625 for the first level, second level is 625, third level 225, fourth level 25, fifth level is 25, and the sixth level is 200 and what, 25, right? So when we sum everything, we are getting 1750, right, for the summation of what, x minus mu all squared, right? So the population variance, which is represented by this one, is surely going to give us 1750 divided by 60, which is going to give us 291.7. So this is what our population variance. And then if you want the population standard deviation, you are just going to square the population variance to get 17.074. Sorry, 17.079. So this will be what, our final answer. So this is the end for measures of variation. If you haven't subscribed, kindly subscribe to Statistics and Mathematics YouTube channel so that in the end you are going to be blessed. Don't forget to leave your comments at the comment section. Bye.